Let's solve the following system of linear equations by substitution. So let's say we're given 3x minus y equals minus 4 and x plus 3 over 2y equals 8. Okay, so here's our system of linear equations. You can say this is equation 1 and equation 2. And if you recall by substitution, what we want to do is we want to solve one of these equations. It doesn't matter which one. We want to solve one of them for one variable in terms of the other variable. So this one looks a little simpler to solve for the variable x. So let's go ahead and solve that for x. So we have equation 2 is x plus 3 over 2y equals 8. Let's go ahead and subtract 3 over 2y from both sides. These two terms will cancel, which gives us x equals minus 3 over 2y excuse me, plus 8. All right, so we have one equation with a variable defined in terms of the other variable. So what we're going to do is take this expression right here, and we're going to plug it into the other equation wherever we see x, because we see x is equal to this, so we can plug it into this because we see x over here. So very simple. Let's call it substitution. So let's go ahead and substitute in for x. So 3 times our expression for x, so minus 3 over 2y plus 8. Then we have minus y equals a minus 4. And this is the end game. This is what we want to get. We want to get an equation that is defined in terms of one variable, so we can get our variable on the left-hand side and everything else on the right-hand side, and we'll actually get a value for this variable. All right, so let's go ahead and solve for y. We can distribute this 3 into the parentheses, so we have minus 3 times minus 3 is minus 9 over 2 times y, plus 3 times 8 is 24, minus y equals a minus 4. Okay, so let's go ahead and start moving everything over to the other side except our variable, so we can subtract 24 from both sides, minus 24. These two terms will cancel, so we're left with minus 9 over 2y minus y. We can rewrite that as 2 over 2y, so we can have a common denominator. We can combine these fractions in the next step. And on this side, we have minus 4 and minus 24, which is a minus 28. We can combine these two fractions. 9 and 2 gives us a minus 11 over 2y equals minus 28. And we can go ahead and multiply by the reciprocal on both sides to isolate our y. We're multiplying by the negative reciprocal, so we can solve for a positive y. We don't want a negative y. So that term will cancel, which gives us y equals, these two terms, these negatives will cancel, so 2 times 28 is 56 over 11. So we actually have a value for one of our variables. Y equals 56 over 11. And since we have that, we can plug it into one of our equations. Doesn't matter which one, and we can solve for our other variable, x. Let's go ahead and plug it into equation 2, since this one's fairly simple. So we have x plus 3 over 2 times y, which is 56 over 11, equals 8. We can simplify in this step, factor out a factor of 2 from both of those numbers. So we have x plus 3 times 28 is 84 over 11 equals 8. And we can go about isolating our variable x. So we can subtract 84 over 11 from both sides. Minus 84 over 11. These two terms will cancel. That'll give us x equals 8 is the same thing as 88 over 11. Now we have a common denominator here, so we can combine these two fractions. And x equals 4 over 11. So here's our value for our other variables. So we got values for both variables, so we can write our exact solution for this system of linear equations. We have the solution 4 over 11 and 56 over 11. This is the point where these two lines intersect, and we can prove that by plugging in 4 over 11 in for x and 56 over 11 in for y. We can do that in both equations, and both of them will remain true. That means we have a solution for our system of equations. So let's go ahead and do some more. Let's get a little more practice. We're solving linear systems of equations by substitution. So next we have minus 4x minus 2y equals minus 1. And we have x over 4 plus 6y is equal to 0. So here is our system of linear equations. We have equation 1 and equation 2, if you will. And we want to, the first step is we want to take either equation and solve for one of our variables in terms of our other variables. So this one has fractions, so I'd rather deal with this one. So let's go ahead and solve this one for y. So we have equation 1 is minus 4x minus 2y equals minus 1. Let's go ahead and solve it for y, so we can isolate that by moving everything else to the right-hand side. So we can add 4x to both sides. These two terms will cancel. So we have minus 2y equals 4x minus 1. And we can isolate y by dividing through both sides, through each term, by minus 2. Those two terms will cancel, so we have y equals 4 divided by minus 2 is just a minus 2 times x. These two negatives will cancel, so we have plus 1/2. So we have one variable in terms of another variable, so we're going to substitute this expression into our other equation wherever we see y. So this is what's called the substitution method. So let's go ahead and do it. We have x over 4, substituting into equation 2, plus 6 times our expression here, minus 2x plus 1/2 equals 0. Now we can go ahead, we have our equation in terms of one variable, so we can solve for a value. We wanted a value of x, so let's go ahead and solve for it. We have x over 4, excuse me, that's x over 4. X over 4. We can go ahead and distribute this 6 into the parentheses, so we have 6 times a minus 2x is a minus 12x. 6 times 1/2 is 6/2, or just 3. And now we can start moving stuff to the other side. So we have minus 3. We're subtracting 3 from both sides. That means we have these two terms cancel. We have x over 4. Let's go ahead and rewrite this in this step. Let's rewrite x over 4 as 1 over 4x. So we can isolate the coefficient and the variable. We can separate them. We can rewrite minus 12 as minus 48 over 4. So we have a common denominator, and we can combine these fractions in the next step. We have minus 3 on the other side. So let's go ahead and combine these two fractions. This will give us 1 and minus 48 is minus 47 divided by 4 times x equals minus 3. All right, now we can go ahead and multiply both sides by the reciprocal of minus 47 over 4. We want to divide by minus 4 over 47. Once again, we're dividing by minus, so we can solve for a positive x. So that term cancels, so we have x equals, this negative cancels with this negative, so we have 4 times 3 is 12 divided by 47. So we have a value for one of our variables. We have a value for x. Now what we can do is we can substitute this value for x into one of our equations. Since this one doesn't have any fractions, we can substitute it into equation 1. So let's go ahead and do so. We have minus 4 times x, which is 12 over 47, minus 2y equals minus 1. Now we have a single equation with a single variable that we can solve for. So let's go ahead and do so. We have minus 48 over 47 minus 2y equals minus 1. We want to isolate our variable y by moving everything to the other side, so we can add 48 over 47 to both sides, and plus 48 over 47. These two terms will cancel, so we have minus 2y equals, minus 1 is the same as minus 47 over 47. Now we have a common denominator to combine these fractions with in the next step. So we have minus 2y equals minus 47 and plus 48 is just 1 over 47. And we can do the last step. We can divide both sides by minus 2 or minus 2 over 1. That'll cancel and give us a positive y. We can flip the second over here and multiply. So we have 1 over 47 times a minus 1 over 2. All right, so that'll give us a minus 1 over 94. We have a valid value for y. We have a valid value for x. We can check that by plugging both into both linear equations, which I'll leave you to check. It's a good practice. So let's go ahead and state our exact solution for this system of equations. X is 12 over 47, and y is minus 1 over 94. I didn't say it wasn't going to be tedious to check it, but ugly answers are very common in the real world, so let's just get used to them. And this is the point where these two lines intersect. So that's the main most important thing that we want to take away from this. We're out of time, so we'll do some more in the next video using solving linear systems of equations, solving them by substitution. So I'll see you in the next video.